So we are on, this is the second page of the notes packet this is starting building block 3. But what I was saying earlier is we covered building block 2 on Monday, and then you have the Delta Math practice. Now we're going to be in building block 3 for a few lessons. It's broken down. You can see the next few pages are all building block 3. So that's why I have the point 1, point 2, point 3, point 4. Okay, but today we're doing the building Unit 7 building block 3.1, which is over end behavior and limits. Okay, so we're going to start, and I'm going to show you in Desmos how to view a table. If you have like a TI-84, TI-83 or app on your phone that emulates those, that's fine. You can use that and use the table function. But look how far spread these X values are. We've got 10,000, 1,000, 110 in both the positive and negative. So it would take a while to scroll through. If I'm going to show you if you're using the calculator. This will load in a sec. How you can jump from specific number to specific number so that you're not having to scroll so long. Okay, so if you go to y equals and enter your function here, and then you go to second window, so where it says table set, table start, you can put a specific value that you want to go see the y value for. Okay, and the change in table can be anything. Typically it's a 1. Okay, so I want to go to negative 10,000 instead of scrolling down to negative 10,000. I would type that in here, and then I would go to the table by going to second graph, and then I could see it's 0.6666. Okay, so that's the first value in that table. Okay, and then I could go back and say, okay, now I want to see negative 1,000. And go back. Okay, that's 0.666. Instead of 4 6s, it's only 3 6s, right? Are y'all seeing that? I'll write that down. What we've done so far. Okay, so this was negative. My thing is being real funky for some reason, and it's like moving things down when I write in the table, so just bear with me. But that was negative 0.6666. Isn't that weird? I don't know why it's doing that. Yeah, it is negative. Oh, wait, was it negative? Good question. No, it is not. It is positive. Good catch. I'll try and rewrite that neater. 0.6666. Yeah, looks a little better. Okay, and then at negative 1,000, it was just 0.666. Okay. Now, you can keep doing that in your calculator and keep going to second window and going to the exact number you want to go to and checking. Okay, but I'm also going to show you how to do this in Desmos. I'm going to type that function in as my y value. Now, you go to this plus sign and you want to do a table. So the first thing I need to do is get rid of these subscripts, these little ones at the X there. Go there and delete them. I just want X. The subscripts sometimes mess it up. Okay. Now instead of Y, I'm going to put the actual function here. So I'm going to put (2x) squared 2 over 3x squared so instead of having a y column, I have the actual function typed out there. Okay, and then I fill in the x values that I want, which I know are negative 10,000, negative 1,000, negative 10, and then positive 10, 100, 1,000, 10,000. And as I type those, notice the y value or the function value automatically filled in for us. Okay, and those are the same numbers we got in the graphing calculator, right? So this, you can see them all together at once, whatever x values you want. So I prefer Desmos. If you want to use a different calculator, that's okay, you can. I think Desmos is just easier and quicker. Everybody good with that? How we did that? Again, it was the plus sign here, table, and then I made sure that it's just x here, and then the whole function here. Good? Okay, so I'm going to go fill all of those numbers. So then it goes down to 0.66 and then 0.6. Okay, and then the positives were 0.7333, I believe, and 0.6733 and 0.6673 and then 0.6667. All right, so now we have two questions to answer about this. Is what is happening to the values of f of x as values of x get very small? As values of x get very small. So where on the table should I be looking for as values of x get very small? The left, right? As x gets more negative and more negative. Okay, so as the values of x get very small, that's as we go this way, right? Okay, x is getting smaller. Okay, so we start here, we're starting in the middle, okay, and we're going to look left. So what's happening to these numbers as we go more and more left? It is increasing incrementally, but is it increasing to a specific number? What is 0.6 repeating? 2/3. So doesn't it seem that these are just getting closer and closer and closer to 2/3? Okay, so that's what I'm going to say. I'm going to say, okay, so the values of f of x are approaching 2/3. Okay, or if you want to put it as a decimal, that's 0.6667, right? It's 0.6 repeating. You can write it in either way you want. But so as x gets smaller, f of x approaches 2/3. What about as x gets very big? So that's going to be in the opposite direction here, isn't it? Okay, so x getting bigger is going to the right. So we look at these numbers. So we're at 0.73, 0.673, 0.6673, 0.6667, then it'll be 0.66667, right? So what's it approaching? Same thing, 2/3. Both sides are approaching positive 2/3. Oh, fantastic. I'm going to mute this video so you don't have to listen to all this. Renora Abdallah, Lillian Alani, May Allen, Okay, finally that announcement is over. All right. So what I was saying is, as x got really, really small, we went to negative 10,000, it was approaching 2/3. The f of x was approaching 2/3. As x got really, really big, we went up to positive 10,000. Okay, f of x was also approaching 2/3. Okay, what do you think? We don't have a picture of the graph. We just have the values. But this is talking about the left side of the graph and the right side of the graph, correct? So as you look on the left side when x is real small, and you look on the right side when x is real big, if they're approaching a specific value, what do you think that means? Yeah, say that louder. There is an asymptote, okay? There must be a horizontal asymptote at 2/3 that the graph is approaching. Does that make sense? Okay, and you don't have to be able to sketch this yet. We're going to get into more detail on this yet, but those of you who need that visual, so there is a horizontal asymptote at 2/3. Now, we don't know what's happening in the middle of the graph. We are just talking about the ends. The left side of the graph is approaching that and it's this number is positive, and it's looks like it's getting bigger to get to it, doesn't it? So it starts at 0.6 and then 0.66. So it's approaching that asymptote from down here, isn't it? Coming up to 2/3, right? This one, the number's getting smaller until it gets to 2/3. So it's coming down to 2/3. So I know that's what the ends of the graph are going to look like. I don't know what's happening in the middle. I don't know exactly where that y-intercept or x-intercept is. I don't know if there's a vertical asymptote or a hole in there somewhere. I'm just talking about the ends right now. Do y'all get that? Okay. So I'm going to get the highlighter. So it's approaching 2/3 this way, and it's approaching 2/3 this way. That's all we know. That's all we're worried about today. We good? We talked yesterday, or not yesterday, earlier in the week, we talked about factoring all of these out and figuring out where there's a hole and where there's a vertical asymptote. Now we're talking about, what about the ends of the graph? What's happening at the ends? Okay? We're going to do that same thing with number 2. I already put it while the announcement was going on. I went ahead and typed that into Desmos so we can fill in this table. Now, these are in scientific notation. It means these numbers are so small. You have to just remember, I won't write them in scientific notation. I'll put them as regular numbers on here for you. Okay, but you need to remember that, well, now I can't see. The exponent. I need to see what the exponent was. So when you have the exponent, when it's times 10 to a negative power, that means you need to move this decimal 5 places to the left, right? And if it's positive, you would move it that many places to the right. So all of these in scientific notation have a negative power. So that means the number is really, really, really small. If it was a positive power, that means the number is really, really, really big, right? Okay, so I'm going to write these out. That is negative point, and then they're saying move it 5 places. So I move it around the 5, that's 1, and then 4 more. So there's going to be 4 zeros and then the 5. Okay, so 0.00005. And then this one is only moved 4 places. So that means there's going to be 1 less 0. So it's going to be negative 0.0005. Okay, and then the next one only has 2, it's 0.005. And then we're at negative 0.1. And then on the positive 10, it's 0.03, repeating. What in the world? I don't know what is going on. It's so weird. Okay. And then we're at 0.004, and then I guess that would round to an 8. I'll put another 3 here. I don't. Y'all, that's a 4. Okay. I know. It moves, and not all of it moved. That was weird. Okay. And then at 1,000, we're back to scientific notation. So that means there's going to be 3 zeros before this 4. So 0.0004. And actually, that would be a 9, 7 after that. So that's actually going to round up to a 5. 0.0005. And then 0.00005. Okay, so we got those all filled in. Now, let's answer those same 2 questions. I can't remember what color I used going in which direction. Okay, small was blue. So as x gets very small, so going in this direction, what's happening to f of x, to the y value? What's it approaching? What's it getting closer to? It's not getting, I know what you mean when you say smaller, but smaller would be more and more and more negative, right? This is getting less and less negative, right? The number is getting smaller, but since they're all negative, it's actually going up, isn't it? Yeah, but it's going up toward what? What number is it approaching? 0. This is getting, as we go left, this is getting closer and closer and closer to 0. Okay, so I'm going to write that. I'm going to say the values of f of x are approaching 0. Okay, now what about as x gets bigger? X gets really big, so going to the right. .03, 0.004, 0.0005, 0.00005. Also approaching 0. But this time the number is getting smaller. It started bigger, it's coming down to 0. These were coming up to 0. These were coming down to 0. Again, a visual for that. The left side, we said they're coming up to 0. So that means it's below the x-axis and it's approaching it like this, right? And this one, they're coming down to 0. So it's approaching it like this. That's all we know. We don't know what's happening in the middle, but I can tell you what's happening at the end. Good? Okay. So let's talk about some terminology, some vocabulary you need to know. So what is a limit? A limit is a value, a function approaches but does not reach, or actually I should say does not have to reach. It can reach it on occasion. It does not have to reach. Okay, so isn't that what we were just finding up here? Weren't we figuring out what f of x, the function, was approaching on the left and right? So that's what we were finding. We were finding the limit of that function. So when you find what's happening on the ends of the graph, you're finding the limit. The limit is the actual number that it is approaching. Okay, now the end behavior describes obviously the behavior of the graph. Okay, so it describes what's happening to values of f of x, so the function, what's happening to f of x as x approaches positive or negative infinity. So that means as x gets really, really big or really, really small, right? We just didn't use the word infinity and negative infinity up here. We said as x gets very small. Well, x gets very small, doesn't that mean x is approaching negative infinity? And x gets very big, doesn't that mean x is approaching positive infinity? Okay, so we were doing this up here, we just weren't using the terminology yet. We were finding the limit, okay, based on the, we're finding the end behavior, which gives us the limit. We were looking at the end behavior. Now there is what's called limit notation for end behavior. Okay, so we're going to look at this graph here. This graph, I would say, so as x goes toward negative infinity, because this would be negative infinity on the left, right? So x approaches negative infinity. What's f of x doing? This, for f of x, that would be infinity, and this would be negative infinity, right? Would be positive infinity for x. So as we look to the left, what's happening to this graph? What are the f of x values going to? To negative infinity. They're going down. Okay, so f of x approaches negative infinity as x approaches negative infinity. Now we're going to write that in limit notation. So we abbreviate limit as LIM, and I don't know why I do this. I do my L's in cursive like that. I do that for logs too. I think it's because just a lowercase l looks like a 1, and so I tend to do the loop. Okay, so LIM, you can use whatever handwriting you want, cursive or print. So the limit of f of x as x approaches negative infinity. This is how we write this. So under limit, you put what x is approaching with x arrow and then whatever you're approaching, negative infinity. F of x is, okay, so what is that limit? What did we say it's approaching? Negative infinity. So the answer, the limit is negative infinity. Okay, the end behavior written in limit notation is this. So we would say the limit as x approaches negative infinity of f of x is negative infinity. So I'm going to do some highlighting to try and correspond a couple of things for you. Sure. So when you see this, the limit as x approaches negative infinity, that means the left side. Okay. And when you see, I already used blue and yellow earlier. Let me. F of x is negative infinity. That means down, right? Y is going down, negative infinity. That means going down. Okay, so it's falling. So the graph is, it falls left. The left side falls. The left side's going down. Now the right side, I would say the limit as x approaches infinity of f of x is, so let's go to the graph and do the same thing. So as we go to the right, so as x approaches infinity, what's happening to f of x? I move that down a little. It's getting a little crowded up here. What did you say? As we go to the right, what's happening to f of x? Rising, right? So f of x approaches infinity as well. So this limit is infinity. Some other colors to color code for you here. So the limit as x approaches infinity, that means right. That's the right side of the graph. As x approaches infinity, that means x is getting bigger. Purple. And when you see f of x is infinity, that means it's rising. It's going up. Because the y value is going to infinity. So this graph falls left, rises right. This is the limit notation for that. And this is what you have to be able to write and read. But that's what it means in layman's term. It means it's falling on the left, rising on the right. You okay with that? All right, we're going to try that on the back. I'm going to try a couple of examples. So this time we're given a table to fill out, but we're also given the picture. It's a lot easier with the picture. Okay, I'm going to go ahead and tell you the values, save us some time from actually going to Desmos and typing them in. So go ahead and fill in the table with me. This is -1 times 10 to the 12th. That means the decimal needs to be moved 12 places to the right. That means this is a really, really big number, right? Really, really big. Well, I say really big, but it's negative. So it's actually really, really small. So it's -1 times 10 to the 12th. If you want to know what that is actually written out, it's going to take some room because you need 1, 2, 3, 4, 6, 7, 9, 10, 11, 12 zeros after it. It's that number. Yep. So maybe scientific notation is better for this one. Okay. And then this is -1 times 10 to the 9th. Okay. So still really, really small, really, really negative, but not quite as much, right? And then it is -1 times 10 to the 6th. Okay. And then it's -958. What's going on with my little thing? And then we're to positive 962. And then 999,602. And back to scientific notation because they get too big. 10 to the 9th. And 1 times 10 to the 12th. But this time positive, not negative. Does that match our graph? Let's see. I already forgot. Was blue left or right? I was using blue for left. Yeah. Okay. So as we go, as x gets really, really small, that's over here. Is it going down? Does that f of x values match what the graph is showing? Yeah, it's going down. Okay, and as x gets really, really big, look at these y values, these f of x function values. They're getting really, really big, aren't they? Does that match the graph? Yeah, it's going up. Okay, but we want to write this either using the table, you got to be able to read the table, or using the graph. You can read the graph as well. Okay, we want to write the limits, the end behavior in limit form. So the limit as x approaches negative infinity. So is this the left or the right? Left, because it's x approaches negative infinity. So the left side, the left side limit is what? What's it going toward? Negative infinity, right? Yeah, negative infinity. It's going down forever. It's going to negative infinity. So sometimes these are specific numbers like 0. Okay, if there's an asymptote that it's approaching. This doesn't have an asymptote, so it's just going down forever to negative infinity. Okay, so that's the left-hand side in behavior. Whoa, what happened there? Whole thing. Okay, now we're going to do the right side. So the limit as x approaches positive infinity of f of x is what? Infinity, positive infinity. It's going up on the right. You want to write it in layman's terms, you can. It's not going to be like that on a test, but just for the notes to help you understand, this means it's falling left and rising right, which is exactly what the graph shows, right? Falls on the left, rise on the right. You feel okay about that one? All right, uno más. All right, this is -1. Oh, this one does not need to be. Hang on. Don't do scientific notation. This one's not that bad. I'm going to write it out. This would be -0.001. -0.01. -0.098. -0.781. And then 1.1364. 0.102, 0.01, and 0.001. What's happening on both ends? What's it approaching? As you go really small, as x goes really small or really big, so the left and right, and you can see it in the graph, what are they getting closer and closer and closer to? 0. There is an asymptote here guiding that end behavior, saying it's just going to keep getting closer and closer and closer to 0. So both the left approach 0 and the right. You'll feel okay about that limit notation? I hope so, because that's the bell. We'll practice this tomorrow. And let me stop this recording and I'll talk to you.